We're now going to talk about what's called the end behavior of a polynomial. When we say end, we mean the negative infinity end and the positive infinity end, which aren't technically ends. It's just when we draw a graph, we have the left end of the graph and the right end of the graph. Okay, we call that end behavior. When we say the left, we mean as x values approach negative infinity, and when we say right, the right end, we mean as x values approach positive infinity. So here's what we're saying when we say end behavior. If you were to plug in numbers for x that are more and more negative, okay, what do I mean by more and more negative? Well, like, negative 100, okay, then negative 1,000, then negative 10,000. Okay, your numbers are becoming more and more negative. Okay, if you plug in numbers for x that are more and more negative into the polynomial, do the y values get more positive? Do they get larger and larger and larger? And we use an up arrow for that. Or do they become more negative? Do they become more negative just like the x values are becoming more negative? Then we're saying the same thing for the right side. If you plug in numbers for x that are more and more positive, like, positive 100, okay, then positive 1,000, then positive 10,000. You're plugging in numbers that are bigger and bigger and bigger. They're getting closer to infinity. So, 100 is closer to infinity than 10. 1,000 is closer to infinity than 100 is. And 10,000 is even closer to infinity than 1,000 is. And if you plug in numbers for x that are more and more positive, do the y values, the output values, do they get more positive or do they become more negative? And when you consider both of these possibilities, there's 4 possibilities that can come out. A polynomial can have both ends become more and more positive, meaning if you plug in negative numbers, your answers become more positive. And if you plug in positive numbers, your numbers become more positive. Or the second possibility is all of your answers can become more negative no matter what you plug in. So if you plug in negative numbers, you get negative numbers. If you plug in positive numbers, you get negative numbers. That's 2 down arrows. These 2 right here are a mix of each. This one says on the left side at negative infinity, you get negative numbers. And on the right side at positive infinity, you get positive numbers. And then the opposite of that is if you plug in negative numbers, you get positive numbers as answers. But then if you plug in positive numbers, you wind up getting negative numbers as answers. Okay? And this may seem a little confusing right now, but as we progress through this and as you do more of them, it'll make a lot more sense. All right, so let's fill out this table here. We have 4 functions. We have f of x equals x squared. We have f of x equals x to the 3rd power, or x cubed. Then we have f of x equals negative x squared. Then we have f of x is equal to negative x cubed. So what we're going to do is we're going to plug in negative 100, and then we're going to plug in negative 1,000 to see what happens on the left side of this function, of each function. Then we're going to plug in positive 100 and then positive 1,000 to see what's going to happen on the right side of the function. Then we're going to record end behavior. So if we plug in negative 100 into x squared, what we're going to have is negative 100x squared. Well, we know that a negative times a negative is a positive, and 100 times itself is 10,000. So this is going to be positive 10,000. Okay. Now if we do negative 1,000 squared, that's negative 1,000 times itself. So a negative times a negative is a positive, and 1,000 times 1,000 is a million. And so that's going to be positive 1 million. And what that means is, as we plug in negative numbers, more and more negative, look, we go from 10,000 up to 1 million. Those are both positive numbers and becoming more positive because a million is more positive than 10,000 is. Therefore, the left side end behavior for x squared is gonna be an up arrow because the numbers are becoming more positive. Now let's look at the right side. If we plug in 100, 100 squared, 100 times 100 is 10,000. We already learned that, okay? So that's positive. And then a larger positive number is 1,000 squared is 1 million. And 1 million is even more positive than 10,000. And therefore, the right side end behavior is also going up to positive numbers. Therefore, the end behavior of x squared is positive positive, or left side positive, right side positive. Okay. Let's now try x cubed. Okay. Well, we know that a negative, so we got negative 100 here. Okay, and a negative times a negative times a negative. Well, a negative times a negative is a positive, and then a positive times a negative is a negative. So this is going to wind up being a negative. This is going to be a negative number. Negative. And 100 times 100 times 100 is, let's see, that's a million. So we're going to have negative 1 million. Okay? Negative 1 million. So look, that's a negative number. So when we plug in a negative number, we get a negative number as an answer. And over here, it's going to be the same. Negative 1,000 times itself 3 times. So negative 1,000 times negative 1,000 times negative 1,000. That's a negative times a negative times a negative. That's going to be a negative. And 1,000 cubed is 1 billion. Let's see if I can squeeze that in. That's we're going to have to fit 3 more zeros. And look, this is even more negative than negative 1 million. Negative 1 billion is even more negative than negative 1 million. And therefore, the left side end behavior is down. And then positive 100 to the third power is just 100 times 100 times 100, which is 1 million. And that's a positive number. So a positive number gives us a positive number. And it's the same thing here. 1,000 cubed is positive 1 billion, which is even more positive than 1 million. And therefore, as you plug in positive numbers, you get positive numbers. And therefore, the end behavior is negative on the left, positive on the right. Okay. We've already seen these numbers, but now what we have is negative x squared. And so what we're going to do is we're going to do negative 100 squared, but then we're going to reverse the sign because we're making it negative. Okay, well, we already know that negative 100 squared is 10,000. So if we put a negative on it, that's negative 10,000. So for negative x squared, if we plug in a negative, we get a negative. Okay, and it's the same thing here. This one becomes negative 1 million, which is even more negative than negative 10,000. So the end behavior of negative x squared on the left is negative. It's down. And then here, the negative of 100 squared is, again, negative 10,000. And the negative of 1,000 squared is negative 1 million. And so here, when we plug in positive numbers, we get negative numbers. And therefore, that means that the right side end behavior is also negative. Down here, we're going to take the same thing that we got up here, negative 1 million, but we're going to make it negative. We're going to do the opposite of it because it's negative x cubed. So the negative of negative 1 million is positive 1 million. So on this one, if we plug in a negative number, we get a positive number. Okay, and so now we'll plug in negative 1,000 into negative x cubed. Now up here, when we plugged in negative 1,000 cubed, we got negative 1 billion. But we're going to do the negative of negative 1 billion, and that's positive 1 billion. And so here, when we plug in a negative number, we get a positive number. So for negative x cubed, plugging in negative numbers gives us positive numbers. And therefore, we are going to So the left end behavior on negative x cubed is positive. But now look, when we plug in positive numbers, up here we did the same thing. 100 cubed was 1 million. But now we're going to do the negative of it because this is negative x cubed. So we plug in a positive, but we get a negative. We get negative 1 million. And then on this one, when we plug in 1,000, we get negative 1 billion. And so as we plug in positive numbers, positive 100 and positive 1,000, we get numbers that are more and more negative. So the end behavior on negative x cubed is negative, okay? And so what I'm going to now show you is I'm going to show you the secret why this works. It has to do with the lead coefficient, whether it's positive or negative, and it has to do with the degree, whether it's even or odd. And so end behavior is based on the lead coefficient and the degree. It's very simple. You can go ahead and write this right into your notes. If the lead coefficient is positive and the degree is an odd number, then this is your end behavior. You're negative on the left and positive on the right. If the lead coefficient is positive and the degree is even, you're positive in both directions, positive on the left and positive on the right. If the lead coefficient is negative and the degree is odd, then you're positive on the left and negative on the right. And then if the lead coefficient is negative and you have an even degree, then both of them are negative. Now there's two things I want to say here. The first one is, look at this. The lead coefficient always determines the right side end behavior. Positive lead coefficient is always positive on the right. And you'll see here, look, positive lead coefficient, positive on the right side. Here's negative lead coefficient, and you can see that we're negative on the right side, okay? Now the other thing is this, note that when the degree is odd, the end behavior is opposite. See, degree is odd, end behavior is opposite. But when the degree is even, the end behavior is the same or even. Even degree, even or the same end behavior. Now let's finish off this video with some examples. Let's identify the lead coefficient here. Well, here's the lead term. The lead coefficient is -5, and the degree is 8. Okay, that's a negative lead coefficient and an even degree. That means our end behavior is down, down, negative, negative. Okay, on the second one here, this looks like our lead term right here, 3x to the 10th. So the lead coefficient is 3. That's positive. And the degree is 10. That's even. And so then the end behavior is going to be up, up, or positive, positive, okay? This one's in factored form, so it's a little harder to tell, but we can see that this is, we've got negative 1 squared, so that's 1, and we've got -2 here, so -2 times 1, because -1 times -1 is 1, and so the lead coefficient is -2. But we have here, whoops, lead coefficient is -2. But here we have 2 x's and 5 x's for a total of 7 x's. And that means that the degree is 7, so that's an odd degree. So negative lead coefficient, odd degree means positive on the left and negative on the right. And then here we have 9 x's, 4 x's, and this x minus 7 is to the first power, so that's 1 more x. So 9 plus 1 is 10, plus 4 is 14, so the degree is 14. Lead coefficient, well, we have a 1 here, and then we have, this is -1 to the 4th power, -1 to the 4th power just equals 1, and then there's nothing, there's a 1 in front of here, so it's just a bunch of 1s, so the lead coefficient is 1, so that's a positive lead coefficient, a degree that is even, and therefore we are positive, 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 okay?